Hello, everyone, and welcome to the 29th talk in our NOAA Environmental Leadership Seminar Series. The goal of these NOAA-wide seminars is to showcase examples of NOAA's leadership and the impact in environmental science by those who lead it and make it happen. My name is Ariel Sanders. I'm a class of 2021 scholar from NOAA's Educational Partnership Program with minority serving institutions. I'm currently enrolled as a junior at Hampton University, majoring in biochemistry, and I will be serving as your MC today. I'd like to take a moment for a few acknowledgments and webinar details. First, I would like to thank the NOAA Science Council and the team that puts together these seminars, without whom none of this would happen. First, we have Hernan Garcia with NOAA Nestis, National Centers for Environmental Information, Sandra Clare with NOAA Nestis Office of the Deputy Chief Administrative Officer, who serves as the Chief Administrative Officer, Katie Rowley with NOAA OR, NOAA Central Library, and Robert Levy, NOAA Studio Production Manager. We'd also like to thank the captioner with Federal Relay Captioning for making this webinar more accessible. We often have staffers assist us for the NOAA leadership seminars during the Q&A, and today we have Tony Marshak and Sandra Demberger, who will be moderating the questions and answers. Second, I would like to share some seminar logistics. All attendees are muted and questions will be addressed at the end of the webinar. Please type all of your questions and comments into the Q&A box at any time, and we will address as many as we can at the end of the seminar. We are recording this seminar for later viewing. So today's NOAA Leadership Seminar is titled Researching Resilience, Science for the Largest Environmental, Social, and Economic Challenge of the Century. And our speaker is Dr. Stephen Thur. Woo! So Dr. Thur is the director of the National Centers for NOAA's Coastal Ocean Center, NOAA's Coastal Ocean Science, and he's with NOAA's National Ocean Service. So he oversees approximately 260 staff members and operations of 5 marine laboratories with an annual budget of around $70 million. His career with NOAA has focused on applying science to the management, restoration, and conservation of marine resources. He has a particular emphasis on how both the biophysical and social sciences are used to sustain coastal ecosystems and the vibrant human communities that depend on them for livelihoods, recreation, and a place for connecting with nature. So Dr. Thur received his Ph.D. in marine policy from the University of Delaware's Graduate College of Marine Studies in 2003. He holds a bachelor's degree in biology and economics from St. Mary's College of Maryland. So welcome, Dr. Thur. Thank you so much for being here, and we can't wait to hear about how NOAA's work can inform adaptation strategies to global scale and climate change. And with that being said, the mic is all yours.
Ariel, thank you very much for that introduction, and welcome to everyone. Thank you for joining. I hope over the next hour that I'll be able to share some of my thoughts in a way that provoke thoughts and dialogue amongst the folks here and those that view the recording later. So to start off with, what do I mean by science for the largest environmental, social, and economic challenge of the century? And in short, that is the impacts of climate change. And I firmly do believe that what we're going to experience over the coming decades will prove to be collectively the largest challenge our global planet has faced in quite some time, and that it will have significant impacts to our environment, to how societies form themselves and interact with one another, and to our economy. And so I'm going to talk a little bit today about the research I see as needed to promote resilience for the next 5, 6, 7 decades, and give you some vignettes of the kind of work we're already doing to try to prepare ourselves for that future. So I have 3 topics. Here's my agenda slide. I'm going to talk about my view of a research thesis in this area, the motivating factors for a body of work that I believe needs to be tackled. Second, I'm going to go through those vignettes, about a dozen examples of the kinds of research that we're currently conducting, mostly within the National Ocean Service and with our partners. And then I'm going to conclude with some thoughts about the research paradigm. And by that I mean how we will be conducting research going forward into the future to address these challenges. So, as Ariel said, we've got a couple of team members helping with some Q&A. If you've got a question as we go along, go ahead and type that into the Q&A box. Tony and Sandra will be curating those for me a little bit later. So, to get us started, the research thesis. So 2021, there were 20 weather and climate related disasters in our country that caused at least $1 billion in damage. So $20 billion weather or climate events in our country just last year. In the 42-year period, from 1980 up through 2021, the annual average of billion-dollar events in our country was 7.7. 42 years, we averaged 7.7 per year. In the last 5 years, we've averaged $17.8 billion disasters in our country. Tremendous increase. Now, those are in inflation-adjusted dollars, so we're comparing apples to apples from 1980 through 2021. But our population has grown, the quantity of built infrastructure we have in our country has grown, and the frequency of the events themselves has increased. And that's going to likely continue into the future. So from an economic harm and social disruption standpoint, we have to do things differently in the coming decades than we have in the past decades. We're here in May 2020. We've had 3 major reports come out this year. 2 from the IPCC, one on impacts and adaptation, and the other on mitigation of climate change. And sandwiched in between those, we had NOAA-led global sea level rise scenarios for the United States, predicting that the amount of sea level rise that we have seen over the past century, we're likely to see an equal amount in the next 30 years. Accelerating rates of sea level rise causing impacts all along our coasts. So what does this mean at a human scale? Unfortunately, images like these have become too common. We have significant damage following point events. We also have more chronic challenges, sunny day flooding in some of our major cities. We've got a couple of quotes from some of those reports and from NOAA's administrator recently about the need to address the impacts of climate change. And from my perspective, when I hear that, what I translate those words to mean is that we have to conduct research that enables our country to respond to these events so that we are wisely investing both public and private dollars going forward into both solutions and the redesigned infrastructure that's going to be necessary for society. My personal journey, and I'm going to take a moment or two to tell a bit of a story, along this path started in 2017. I was invited to a NOAA Army Corps of Engineers meeting in Galveston, Texas, to talk about potential collaborations between our agencies because some forward-thinking folks recognized that we in NOAA have data, observations, modeling capabilities that the Corps could use. So my background, as Ariel said, is in marine ecology and economics. And a lot of the presentations at that meeting were about particle transport along the coast. It was about sediment grain size, things that were outside of my personal realm of experience and also outside of generally the scientific arena in which the folks that work for NCOS, the National Centers for Coastal Ocean Science research. We don't have coastal engineers, for instance, among our team. But that was a watershed moment for me. I came away from that meeting not with the realization of the specifics of the science that the Corps needed, but rather the impact that our science could have on society. So at the time, during one of the introductory presentations, I was told that that one district, the Galveston district of the Army Corps of Engineers, covers the coast of Texas with a sliver of the coast of Louisiana. Their budget that year was in excess of $300 million for coastal development projects. Now at the time, the National Ocean Service's budget was $450 million or thereabouts. So one Army Corps of Engineers district out of 41 around the country had a budget nearly equal to the entirety of the National Ocean Service. And it struck me that if we want to make a difference for NOAA's trust resources, for the mandates that we have been given by Congress for fisheries production, coastal zone management, the protection of endangered and threatened species, among others, we have the opportunity to use our science as a lever to green up, in this case, the Army Corps of Engineers' much larger investment in coastal development projects far into the future. It may be more effective for us to feed science to folks with pockets that deep, constructing projects so influential along our coast. That was an opportunity that I saw coming out of that meeting and has led to a very significant partnership over the last 5 years. That's where the story began, really, for me. Now, that was 5 years ago. This past August, the Army Corps of Engineers released the Coastal Texas Study, something that was 17 years in the making. And the Coastal Texas Study is about the steps necessary to protect the coast of that one state from hazards. And this is an image from their website about the Coastal Texas Study. It involves seawalls, construction of natural islands, tide gates, ecological restoration, pump stations. What I want you to note is in the bottom left. This plan, which is multi-decade, is estimated to cost $29 billion. And that's for one state. Now, Texas is a large state, but it's only one. And so the level of public and private investment necessary in resilience-enhancing activities going forward is going to be massive. It's difficult for me to wrap my head around. And so how can we use our science to more effectively implement those projects so that we are as efficient with taxpayer funds as we can be as a society? So the largest laboratory in the National Ocean Service is located in Charleston. It's the Hollings Marine Lab. And so a moderate-sized coastal city, important to a lot of the folks that I work with on a daily basis. And I've got 3 popular media stories to share with you. And the first one is from the newspaper Post and Courier's website from September of 2020. And downtown Charleston is experiencing significant sunny day flooding. It's an historic city, very densely populated, and has a very strong medical district. And in September of 2020, the headline here was that despite some of the worst flooding that they have experienced in the last couple of decades, the hospitals have declared that they were staying in the medical district. And if you think about community resilience, human communities, the ability for an ambulance to get from a fire station to a citizen in need to a hospital during a major storm event is pretty critical. And yet if those roads are flooded and the ambulance can't transport that citizen to the medical care he or she needs, that's a challenge. That's a major impediment. And that's what we were seeing in Charleston. We had the declaration that those hospitals are staying in September of 2020. 7 months later, here's a news story from Channel 5, Low Country, that the city has decided to invest $14 million to reduce flooding in the medical district, to avoid those problems that I just talked about, so that the ambulance can get to the hospital, so that citizens can get to the doctor's offices for the treatment that they need. So then 7 months later, they decided we're going to drop pretty significant sums for a moderate-sized city into reducing flooding. And then even more recently, just 5 months later, one of the three hospitals capitulates and they say, we're leaving the peninsula, and it's due to flooding and natural hazards. So in the total of 14 months, here are headline stories about one very specific example: public investment in hospitals, shifting from we're staying to we're mitigating the challenge to we're having to head elsewhere so that we can provide the medical services we need to the population that we serve. And that's pretty dramatic. That's very real. It makes it personal. And I think those stories are going to replicate themselves by the hundreds or thousands across our country. So the research thesis: what are the things that I believe we need to be researching to better prepare our country? There are three of them. So the first is that we have to be able to describe the current and anticipated impacts so that we can form decisions and, more importantly, motivate action. And as scientists, while we provide the tools and information necessary, we are somewhat set apart from the decision-making process, and that is appropriate. I think that's completely appropriate. However, we have a responsibility to provide that information regardless of whether it is going to be welcomed or not by the parties that are going to be receiving it. The next two components of the research thesis are prospective research on design elements. So can we, in a very experimental manner, test things that we think are going to be effective at improving resilience, and then export those and do those at scale by those with the responsibility to implement such projects or to develop coastal policies. And the last is retrospective. It's looking at what we've already done to evaluate their effectiveness, to talk about the successes and challenges, to document them. And I think we have to have all three to be successful in a research endeavor. So what I'm going to do now is shift into my second topic, which is to give you some examples of the resilience enhancing research that we're currently conducting. I've got about a dozen vignettes that I'll very quickly go through. So the first couple of these are our work on nature-based solutions, and a couple of them are in strong partnership with the Army Corps of Engineers. So this is an image of Mordecai Island in New Jersey, and the developed coastal community in the image on the left, it's to the right of the image, is Beach Haven, New Jersey, on the barrier island. And so Mordecai Island had been eroding and had broken into two separate lobes, and this uninhabited island was protecting Beach Haven from the westward driven winds across the bay and had an ability to absorb some of the floodwaters to preserve the coastal properties in Beach Haven. And so we worked with the Army Corps of Engineers, who was doing dredging nearby to beneficially reuse that material to connect the lobes of the island, and are long-term monitoring the site to determine whether it is being effective in reaching both the ecological and coastal protection benefits that were designed in the original outside of the project. Second example is very similar to that, close to home for me, I live in Maryland, is Swan Island in the Chesapeake Bay. So in the lower left-hand corner, you can see at the very top edge of that image is Ewell, Maryland. It's a small town. There are very few inhabited islands remaining in the Chesapeake Bay, and the working watermen and waterwomen of those communities are integrated into the fabric of both Maryland and Virginia. These are some of the last places where cultural traditions that stretch back to the founding of our country have persisted. Ewell was protected by Swan Island. It's about a 20-mile fetch from the mouth of the Potomac on the western shore of the Chesapeake across the main stem to the town, and Swan Island protected the town in essence as a natural breakwater. The island was subsiding and eroding. And so we worked with the Army Corps of Engineers, who was doing a nearby dredging project to beneficially reuse the sediment there, and are working with both nonprofit, federal, and state partners to monitor the marsh restoration, the maintenance of the elevation that we provided to the island, and the nearby submerged aquatic vegetation to determine the ecosystem services that are being provided by what was, in essence, a coastal protection project. And so we're looking to hit multiple objectives through a single project and being able to document what worked and what didn't so we can export that elsewhere. A similar but distinct example is our work, which is now over a decade in the making, with Marine Corps Base Camp Lejeune in North Carolina. And so this base, 247 square miles, 14 miles of coastline, is a major training facility for amphibious assaults. And so this is critical for our country's national defense. And the built infrastructure at the base is protected by extensive fringing marsh. That marsh is subsiding and eroding. And the images that you see on the top are one mechanism of how that is occurring. Marsh ponds are formed, and that those ponds start as a small circular inlet that expand in size through multiple tidal cycles to the point where the marsh is fragmented to the point where it's no longer providing the flood protection and storm surge protection of the built infrastructure of the base. And so the military is interested in knowing what they can do to slow or perhaps stop the marsh erosion, because they have quite literally a couple of $1 billion of investment in the infrastructure at this base. And so our staff have worked to determine whether we can use dredge material from the nearby intercoastal waterway to raise the elevation, and whether the pond's expansion can be stopped through the provision of that sediment into the system along with marsh plantings. And any day, in my opinion, that you can do some research on a stand-up paddleboard is a good day. Another example harkens back to my past with NOAA's Coral Reef Conservation Program, and that is the use of coral restoration, in this case, emergency triage of fragmented coral following Hurricanes Irma and Maria in the Caribbean, to reattach those coral to the reef in such a way to provide benefits to what may have been a threatened species, but also to provide the structure necessary to break wave energy in future storms. And why is that important? Here's a schematic that indicates as we move from open water to hit the reef crest, waves will often peak, and the wave energy is dissipated by the submerged reef crest. And what that does, by dissipating the wave energy, you dramatically reduce wave runup along the shore and reduce flooding. And so the value of an intact, healthy, stony coral-dominated reef is that you are maintaining the built infrastructure along the shoreline. And our partners with USGS and academics have looked into the value of this, and they've determined that in Puerto Rico and Florida, those healthy reef systems are amounting to $270 million per year of flood damages avoided on average. That's very significant. And that argues for an increased role in reef restoration to reduce storm-associated flood damage in those communities. Now, unfortunately, the animations that are part of this slide don't work in the Adobe Connect system. But what you would have been seeing are a pair of animations that are intended for decision makers to distill down relatively complex geophysical modeling into mediums of communication that most decision makers can understand. And so what we've done is funded extramurally through our academic partners their research looking at increases in mean sea level rise coupled with wave action and storm events to determine how the shape and slope of a beach, both with fringing marsh and with dune systems, changes over time under various sea level rise scenarios. And what we find is in many locations, the dune system is going to be pushed back significantly, and we are experiencing this already. The first row of developed infrastructure is at significant risk. In natural settings, what we find is that some of the coastal fringing habitats get to a place where they can't further migrate inland, and that we lose multiple components of the habitat because there aren't migratory corridors upland. And those are big challenges for everything from deciding on where to site new development to selection of areas for restoration, which you don't really want to invest in if that restoration project is going to be missing in a decade because of sea level rise and the inability of that habitat to migrate upland. We've also been looking at the terrestrial side of the coastal margin. Now, traditionally, we've focused in the water, but we've been moving upland quite a bit. And some extramural research is looking at the effective ways to establish dune systems for coastal restoration, something that's been generally outside of our purview dating back more than 5, 6, 7 years. And so the image in the upper left is pretty typical for our current constructed systems, in that we have what may have been the remnants of a natural dune with a relatively sharp escarpment leading down to a dune that we have rehabilitated through sand fencing and beach renourishment. And through time, our hope is that those relatively understood systems can withstand future coastal storms. Well, the research we're conducting now is looking at a couple of components, including what is the appropriate slope and breadth of dune systems to allow various species of dune grass to grow up over the landward edge and down the oceanic edge, so that the entire dune system is locked more tightly than it would have otherwise been. Now, the image on the left is fairly typical, particularly along our Atlantic and Gulf coasts following a major storm. We have a relatively steep dune escarpment. We've got significant damage, in this case for private access to the beach, but we also have impacts to public access, and we've produced quite a bit of debris. That system was effective in protecting the houses, but it may not be for the next storm. The image on the right shows a dune system that is much more gently sloped and a beach that's significantly wider. That dune fencing is also, when it was constructed, more than a meter above what was then the dune surface, and now it's sloping down to only a few centimeters. And so it has the ability to trap additional sediment, additional sand, to continue to maintain that gently sloped beach structure, which will allow the vegetation to propagate down the oceanic edge. And so changes in things like design elements for dune systems are leading to enhanced resilience along our coasts. I'm actually really proud of the team that worked with a brand new partner for us in 2021 to create a jointly funded extramural competition looking at resilient transportation infrastructure. We've had long-term federal partners. The Department of Transportation's Federal Highway Administration was not among them. We have identified an overlap in our areas of interest that aligns with coastal transportation. And so we have multiple projects that we are now funding jointly with the Department of Transportation to look at how pavement deteriorates following repeated inundations, and also how design structures can be improved to address the long-term ecological effects of sea level rise. So we don't have repeat instances of what is shown in these two instances. Our hope is that this partnership will spur additional joint funding so that we're looking at resilience research that hits multiple agencies' goals in a manner that is novel for our agencies. Harkening back to our roots. So NCOS started providing a lot of scientific information for the management of our national marine sanctuaries, and we continue to do that and have put a resilience lens on much of that work. Earlier in 2022, the Olympic Coast National Marine Sanctuary put out their condition report, and it focused on 3 large areas. The living marine resources condition, and that's typical. Human activities that have been performed and will likely to be performed within the sanctuary, and the ecosystem services that are provided by those resources to the humans. And so while this is, in contrast to the last slide, a long-term partnership, we are bringing in the additional human components to talk about the condition of sanctuary resources in a way that wasn't necessarily the case previously. And it's done through the lens of how can the information we are providing to the sanctuary make its management more resilient to the challenges it's going to be facing in the future. Not only with their living resources, but also changes in human use of that particular sanctuary. A couple more. So another extramurally funded project is using acoustics to monitor marine mammal presence in the Gulf of Mexico. And so as keystone species, marine mammals and changes in their distribution patterns can tell us things about different trophic levels within the ecosystem that we may not be able to identify through other observing systems. And so we're looking at the distributional patterns to determine if there are changes that we need to make in the human management of the system. Everything from leasing oil and gas sites to the development of offshore wind or the siting of offshore aquaculture could be impacted by distributional changes of these species, many of which are threatened or endangered. And so this information, while focused on a very NOAA-esque resource, marine mammals, we've had the Marine Mammal Protection Act now for 50 years, but are conducting that research in a way that informs more than just our direct interaction with those species, but it gives us a sense of how they are indicators of ecosystem health. Going from the warm waters of the Gulf to the colder waters of coastal Alaska, our office does a lot of work on harmful algal blooms. Recently, we have seen species migrations further north and increasing density of those harmful algal bloom species to the point where we are now detecting two toxins, domoic acid and saxitoxin, in seals. And so when you are talking about a food source for Native Alaska communities that they have relied upon for thousands of years, suddenly potentially being toxic, potentially being deadly for consumption, this is something that rips at the fabric of those communities' resilience. And by conducting the research to determine the prevalence of these toxins further and further north, we are providing information that will help them make educated decisions about food security, among other things. And that is another change on a long-term research paradigm, harmful algal blooms, bringing in resilience-related aspects in how we are communicating the results and the types of decision support tools and graphics we are providing. All right, a couple of more. So, we focus very much on the marine side of the coastal margin and on the ecological system. More and more often, we are being asked to pair that with information that can only be gleaned from the social sciences. And so we conducted, as a pilot, a community vulnerability assessment where we looked at things like structural vulnerability, locations of livelihoods, community vulnerability, demographic factors, with flood risk, and overlaid those two to determine areas that may be ripe for adaptation planning. And we started this in our own backyard. We have the Ocean Services Cooperative Oxford Lab. It's in the eastern shore of the Chesapeake Bay in Maryland, in Talbot County. It's a very rural location with a fair number, but not a tremendous number, of different land use types. It was appropriate for a pilot study of this nature to determine whether we can do this, do it well, and produce products that will be useful for county and town level managers. And then members of my team came to me with the audacious idea of going from a rural community on the East Coast to one of the largest metropolitan areas in the country on the West Coast. They took this concept of community vulnerability and tested it in LA County. And so here they looked at sedimentation and flood risk along with structural vulnerability to map areas that are probably necessary for adaptation planning by the county government. So if we can bookend this and show that we can provide useful information products for a rural county and one of the major metropolitan areas of our country, the methodology would likely be applicable for everything in between. And that's what we're working on right now. It's not a surprise to most of the listeners in this seminar that the development of offshore wind energy is a priority for this administration. Well, we've been working with the Bureau of Ocean Energy Management on offshore wind items for more than a decade, before BOEM was actually BOEM, before they were formed as an independent agency. And much of that has been around the concept of marine spatial planning. Where can offshore energy be sited to minimize conflicts with particular natural resources, seabirds, or important hard bottom habitat? But we've also been asked about the human side. and public perceptions of offshore wind energy. In particular, in this study, about the border region between South and North Carolina, which is an area that is potentially ripe for offshore energy development. And what we've done is assisted through the provision of surveys of the local population. South Carolina, roughly 15% of the population in this county, are fairly opposed to offshore energy. In North Carolina, the same region, it's about 23%. More than half are supportive. And so I talked earlier about us scientists needing to be policy agnostic, but this is information that policymakers need so that they can understand public perception and how that will affect things like permitting, siting, and design decisions that they have to make. One final example, one last vignette. This is relatively new research, also externally done, looking at 13 counties in the northern Gulf of Mexico, stretching from Florida through Alabama into Mississippi. Those researchers are connecting geophysical components, water level, currents, and waves, at a really fine scale to model impacts that can be expected under various sea level rise scenarios, and are overlaying census block socioeconomic information on that. And so the image on the left is a really fine scale of Pascagoula, right up along the coast, highlighting, if the images were better and I blew them up more fully for you all, you could identify individual rooftops. They're providing information about likely damage at the census block level to inform things like potential structural damage, leading to how many folks might need temporary or long-term shelter following a storm event under various sea level rise scenarios. So some of this was known before, some was new modeling. Putting the two together is going to provide a level of detail that coastal managers in this 3-state area need and don't yet have. And that's exciting to me. I think we need more of that. All right. So now, third topic of my presentation. It's about the research paradigm, and I want to convey two thoughts in the next couple of minutes before we get to the Q&A. And the first thought is that I think there are periodic episodes that are ripe for a research program to investigate. And in the last 13 years within NOAA, I think there have been 3 instances of such a set of natural experiments for us to focus resilience research around. And I will admit, in my personal opinion, I think we missed the first 2, and we have the opportunity now for the third. And so before I joined NCOS, I was part of the NOAA Coral program and had the opportunity to be involved in what at the time was a very significant public investment in NOAA for habitat restoration. And in my view, resilience-related projects and habitat restoration projects are 2 sides of the same coin. And which side you're looking at depends primarily on the program funding the work. You could spin a resilience project into a restoration project, and you can ensure that your restoration project has elements that are intended to promote additional resilience. So in 2009, the agency received $167 million from marine and coastal habitat restoration. And those went to fund 125 projects in 24 states and territories. These at the time were fairly large-scale projects, a couple of $1 million apiece on average. Unfortunately, there was no research program set up to determine long-term how those projects worked, so that in future instances, we would have the benefit of that research to better design future habitat restoration. Now, in this instance, there was funding for limited monitoring, primarily for the purposes of adaptive management, to know whether a particular project was meeting its objectives and whether it should be changed somehow mid-course within the first couple of years to hit those project-specific objectives. Now, I will give credit to my fisheries colleagues. These images are from the Office of Habitat Conservation's website. They did recently go back and do a 3-part retrospective about the jobs that were created, the living marine resources that were aided, and the capacity for coastal restoration that was enabled by these projects. And I think that retrospective is wonderful. I lament that we did not have a parallel research program to do long-term monitoring and potentially experimental studies in these sites. The second opportunity I think we also missed. In 2013, Superstorm Sandy hit, tremendous impact in the Northeast. NOAA received a total of $476 million in the Sandy supplemental. And the vast majority of that money did not go to research. However, in this instance, there was just under 75 of that $476 million sent to OAR for the purposes of additional research, which I think is very positive. Now, from my perspective, sitting in the National Ocean Service, one of the challenges was that none of that money went to ecological research. It was invested in things that we absolutely needed: better forecasting for both local storms and large-scale global modeling, and the procurement of high-performance computing we need to run those models on. So completely appropriate, but there were areas in the Northeast that had variable impacts from Superstorm Sandy because of the natural and built defenses that were around. We saw less flooding and less property damage in areas that were near to natural marsh and dune systems than were present for seawalls, riprap, and bulkhead. Academics have anecdotally given case studies of those findings, but we did not have the resources or redirect existing resources to a research paradigm to capture that ephemeral data and monitor long-term for recovery. That brings me to the third opportunity. So, last year, NOAA received just under $3 billion for the Infrastructure Investment and Jobs Act, and that's dedicated to 16 distinct areas. 8 of them are listed on this site. 7 of those are for external cooperative agreements and grants for restoration or resilience. And the last one is internal capacity to aid with getting things permitted and consultations done. So roughly $2 billion over 5 years will be spent on restoration and resilience activity. And unfortunately, there wasn't any money dedicated to researching or long-term monitoring of the projects those $2 billion will be going to put into the ground and into the water. And so now I have the opportunity to put my money where my mouth is. Within NCOS, we are redirecting existing resources to begin a limited program to look back at projects or impacts from these 3 major events. So we will be getting it on the ground with some of the upcoming projects to conduct baseline monitoring before Earth is turned, and then conduct a designed monitoring program to determine efficacy for some of these IIJA-funded projects. We're also going to go back and look at some of the ARRA-funded projects that were given cash in 2009 to determine how they have progressed in the last 10 to 12 years, and determine what we can say about design elements that should be exported elsewhere and design elements that didn't work out quite how we anticipated. So that's going to be limited because it's with existing resources, but we have the opportunity to conduct research that's going to help with the next large one-time infusion. It's my opinion that if we've had 3 of these in the last 13 years, in many of our careers, we're going to see a couple of more. And so we need to be prepared with the research to ensure that those public dollars are wisely invested. That's the first comment I wanted to talk about, a change research paradigm. The second is that many of our projects have been designed and funded because of a single purpose program. So as an example, I mentioned NOAA is receiving funding from IIJA in the amount of $3 billion. $2 billion is for habitat restoration or resilience projects in different categories, and they have a primary purpose. Our colleagues at the Army Corps of Engineers are receiving $17 billion in IIJA funding, 2.5 of which is going for coastal flood mitigation projects, and another $1.9 billion is going for projects to restore aquatic resources. There are specific primary purposes that all of those projects will seek to address, and they are directly related back to the programs that are administering those. But we have the opportunity with smart design and research aiding that design to hit multiple objectives with a single project. This is pair of images of the Southern Flow Corridor project. I'm going to credit NOAA Fisheries again. This was a project that reconnected the waterway to its historic floodplain, and it was primarily done for habitat purposes. And you can see some of the stats there. But it was done in such a way that it addressed the needs of a threatened coho species, to provide blue carbon storage, to increase associated and nearby housing values, to decrease flood impacts to 4,800 acres of a developed community nearby, and to reduce downtime for the local highway because the road remained passable. That's one project that probably just ticked off the missions of 5 or 6 different agencies and the objectives from perhaps half a dozen federal statutes. It's my opinion that we need to have more projects that tick off so many multiple objective reasons, and we need a research paradigm that doesn't just look at fisheries production or public access or the recovery of a threatened endangered species. We needed an integrated research paradigm to address all of those together. So that is what I hope we can achieve together. I am through with my prepared remarks. I hope I spurred some thought about what we need for researching resilience going into the future. I thank you for your attention, and I invite Tony to join me to talk through some of the questions that have been coming in.
All right, well, thank you so much, Steve. Really appreciated that presentation. And hi, everyone. My name is Tony Marshak. I'm an environmental scientist with NOAA's National Centers for Coastal Ocean Science, and I'll be moderating this Q&A portion. And see that a number of folks have already been entering their questions into the Q&A box, and certainly welcome our attendees to continue typing in questions for Dr. Thur, and want to say thank you to everyone for all your great questions. So I'll go ahead and start jumping in. First question is from Summer Ohlendorf, who says, there's a lot of crossover between the topics you've discussed and with building coastal resilience to tsunami impacts. What potential do you see for greater NOS NCOS engagement with the Weather Service's tsunami program and the National Tsunami Hazard Mitigation Program?
That's a great question, Summer. Tony, you were supposed to start with a softball, and that wasn't one of them. To be honest with you, Summer, I don't know that we have any direct interaction with the tsunami program, but I do see tremendous parallels through some of the research we have done looking at the reduction of storm surge and wave energy for instance, along fringing reefs. And so you've probably given us something to follow up on in your first question. Thank you.
All right, thank you. A bit of an easier question from our next attendee, which is what types of interagency efforts is NOAA involved in to address some of the coastal resilience and climate change concerns that you mentioned?
So I've mentioned a number of them throughout the presentation. Our office has pretty extensive partnerships with multiple bureaus of the Department of Interior, U.S. Geological Survey, along with the Bureau of Ocean Energy Management being key among those. We also have extensive partnerships with the Army Corps of Engineers and Department of Defense. I profiled a couple of those. And we have longstanding partnerships with the Environmental Protection Agency as well. So those are some of the more typical partners. Some of the newer ones for us are the Federal Emergency Management Agency, FEMA, and the Department of Transportation. And so we are finding that in the realm of coastal resilience and impacts to climate change, there are more opportunities for us to collaborate, or we are more easily identifying those opportunities than we were in the past. So those are a couple of our strongest federal partnerships, I would say, in this space.
Thanks, Steve. Next question is that NOAA is uniquely positioned to serve the nation and generates several terabytes of open access science-based data per day. However, searching for and accessing that data across NOAA or even within line offices is not quite possible. How could NOAA position itself as an agency that delivers findable, accessible, and interoperable data of known quality?
Yeah, so this is a big challenge. Thank you for the question. I would state that for certain defined users, we have done a fair job of ensuring our data is findable, accessible, and interoperable. And we have the ability to design information support tools and data flows transferability to meet those specific users' needs. Now, what that doesn't ensure is that our data is open and accessible and findable for all of the other users that we are not working in collaboration or direct partnership with. And that is going to be a challenge. In particular, I think that we do a solid job with many of our physical and to some extent chemical data observations. Our biological data is much more challenging to disseminate in a consistent manner that is findable and accessible. So in terms of what we're doing, we have identified a couple of portal-based uses so that we link through a particular portal the generation of a report along with the backstop data that generated that report. So the Ocean Reports tool, which is a partnership with multiple agencies, including our own, is one. We also have Marine Cadastre, which is attempts at one-stop shopping for a number of data layers that others can access directly.
All right, thank you, Steve. Next question is from Dave Chiacchetto, just asking, is there a link to the animations that you included that we can watch later, particularly the NCOS predicting impacts of sea level rise in the Gulf?
Yes, so we can provide that. We have project pages on our website that have those animations. I'll check with the organizers about how best to link that information. But if you're interested, you can send me an email directly and I can provide the links individually.
Thank you. Next question from Douglas Wood. Does NOAA have a study to examine the potential danger to the Pacific Northwest coast by the next slip of the Cascadia subduction fault?
So I am not aware if we do or not. What I can say is that we don't within the National Ocean Service or within NCOS, my organization.
Okay. From Carl Childs, when I triage the current and anticipated impacts of climate change, it seems that food supply chain security and mass migration dwarf all other potential issues. Does NOAA have a role in addressing these concerns?
So I would say yes, in a couple of different ways. And so first is that NOAA has a global role in the provision of authoritative data. And so this set of information is necessary for countries around the world to be able to make decisions of their own. And so we have a trusted data provider role to play globally. At the national scale, there are a couple of things that immediately come to mind. The first is that we have responsibilities under the Coastal Zone Management Act to provide support to states in how they manage their coastal zones, which for our country will be some of the areas that will experience some of the most acute changes in the coming decades. And so things like housing or public infrastructure development policies at the state, county, and city levels can be informed by our coastal zone management support. Second area that we have regarding food security is that we have a very significant dependence on imported seafood for protein provision, and that the agency has a role in promoting both sustainable wild harvest, but as also offshore aquaculture development. And how can that be done in a sustainable way to aid our local food security to reduce reliance upon imports of protein? So those are a couple of ways that we have a role to help in both food security and potential human population migration.
Okay, thank you, Steve. Next question is from Nina Garfield, who asks, is there a conversation within NOS, for example, in the estuarine research reserves or sanctuaries, on designing an integrated research program as they implement current and future infrastructure funding?
So I can't speak specifically to sanctuaries and NEARS. However, I do talk with several of my colleagues that are charged with implementing specific Infrastructure and Investment Jobs Act funding streams, and they are directly communicating with one another to ensure consistency in approach and to avoid unnecessary duplication and overlap of the kinds of things that they will be funding from those various IIJA buckets. It is probably a wise idea for us to touch base with the special places associated with the National Ocean Service, the Estuarine Research Reserves, the National Marine Sanctuaries, and I would put into that bucket our coral reef areas to determine whether there is something that can be done on an integrated or holistic manner system-wide. Thanks for the question, Nina.
Great. And from Gerardo Nixon, who asks, what avenues are being explored to share the data and science collected by NOAA with local communities and industries to allow them to take better actions in planning of their operations? And then he also follows up with, how is NOAA ensuring that our data are standardized to be able to use advanced tools like machine learning to analyze and take action on those data?
Yeah, thank you, Gerardo, for the question. I have a very strong opinion that on the continuum of basic to applied science, the vast majority of what the Ocean Service produces should be on the applied end of the spectrum. And I've said in the past that I want us to be conducting 90% of our research on the 10% end of that continuum that lines with the applied pole. And so for the vast majority of the research activities we start within the National Centers for Coastal Ocean Science, we know the users and often the decisions that they are going to have to make before we start our research activity. And so we often design the studies to achieve the specific information products that they're looking for. And so there is a tight connection. It is not quite co-production with the resource managers, but it is very, very tightly linked. And so we will often provide not only the raw data and reports, but information tools, visualizations that allow them to make the decisions and then communicate those decisions to others. And so I would say the approach we have taken to research is to understand our customer from the outset, rather than doing proscriptive research in search of a manager that will make use of it on the back end. Tony, we might have time for one or two more.
Varis Ranzi, who's asking, how do you sustain the importance of climate change science from one administration to the next?
Ferris, great to hear from you, and thanks for the question. So I would say that the kinds of research that we need to do are going to be important for society regardless of the administration. And I'll give a couple of examples. I think in my presentation I mentioned we've had a partnership with the Bureau of Ocean Energy Management for over a decade looking at offshore wind. And that was long before this administration came in with offshore wind as a priority. I also mentioned we've been working with the Department of Defense and I would say ensuring the security of major training facilities for our military is something that is neither a priority for both of our major political parties. And so by focusing on the impacts we are experiencing and will likely to experience and talking about the uses of the science, rather than getting into the debate of the origins of the change, I think we stay relevant for a longer period of time. And we have seen that we have been able to sustain research activities for more than a decade through 3 or 4 administrations without any significant disruption. And in fact, we've been able to provide information to support new administration priorities because of research we started 3 and 4 and 5 years prior. So I actually think, Varys, this is easier and more frequently done than perhaps is commonly perceived.
Tying with the Coral Reef Conservation Program into your current role with NCOS when addressing coastal resilience?
Yeah, most certainly. Thank you for the question. I'd say the one largest takeaway is how important understanding the local context is. So I worked for a federal program just outside of Washington, D.C., aiding 2 states and 5 territories that have coral reef resources. and the cultural and political context of those in which those ecosystems were set were critically important in how we provided science support and policy support. And so that's what I've brought to NCOS. I think it is the importance of understanding the local user before you begin a research program. And that has aided, in essence, the efficacy and usefulness of our science, and something that I am quite proud of for our organization. Thank you for the questions. There were many others that we couldn't get to. We are at time. Ariel, are you coming back in to say goodbye?
I'm coming. So, Dr. Thur, do you have any last words or comments? Are you good?
Is one of thanks, and that I hope my primary purpose in offering the seminar was achieved, that it continues a dialogue that was started here today about the importance of researching resilience for what our country is going to need for the next several decades.
Well, thank you, Dr. Thur, for a terrific talk, and thank you, Tony, for moderating the questions, and Sandra. Our next NOAA Environmental Leadership Seminar is going to be on June 14th, and our speaker will be Dr. Wayne Higgins. He's the director of the Climate Program Office of NOAA's Oceanic and Atmospheric Research. And we hope you all join us there. And thanks everyone who joined us today. That's all for now. Bye.